This is Randy at BW Parts. I got a machine in here that the customer was complaining that it was welding cold. When we load banked it, it actually would pull a load, but what we found out was that this carburetor, the throttle bushings are completely worn out. And if you look at this, there's all kinds of side play in this. So as he's welding, this is just moving back and forth, and so his welds are inconsistent. So what we're gonna do is we're gonna change this carburetor out. We're gonna put a BW191, which that has the low idle arm linkage on it, so it'll just be a direct replacement fit. So that's what we're going to be doing. We're going to be setting the low idle, the high idle. We're going to be checking the OCVs to make sure that it's consistent with where I set the carburetor at. And that's it. We'll see how it goes. All right, so now that we have this carburetor where we can look at it, you can see all that side play that's in here. Now the reason that this is a big deal is because this whole throttle shaft is moving while you're welding, and this is supposed to stay a constant speed, right? And maybe adjust a little bit like that as you're welding. Now, for the fuel to be able to burn correctly, you have to have 14.7 parts of oxygen to 1 part of fuel for it to burn correctly. So what happens is, with this throttle bushing worn out, your air also gets sucked in from the side, which changes your fuel ratio. So now you're maybe 20 to 1 or whatever. So now it causes, just like if you're using your acetylene torch, your engines run a little bit hotter, the spark plugs are a little bit more white instead of a nice burn ratio on the spark plugs itself. And it's all because of that throttle right here being worn out. Now, if you wanted to test this, you could have this at low idle with it running, and you could hit it with some carb spray right in this area right here. And if your RPMs pick up, then that means your fuel ratio burn is closer to what it should be at 14.7 parts to 1 instead of maybe 20 or 22 to 1, right? So that's that carburetor. So now what we're gonna do is one of the main complaints is when they get a new carburetor out of the box and they put these components on it, that when they put it together and they put the Teflon tape on, what happens is that they get some Teflon tape, just like that little piece right there sitting over the edge. That breaks off and goes into the carburetor and sticks in between the needle and seat and causes the needle not to seat all the way into the seat and causing it to seep fuel. So what I do is I go ahead and wrap this and do probably about 3 wraps, right? So I can adjust it once I have it in place to where I need it at. Then once I get it in here, I peel off all the extra and kind of just get it into the grooves really good. Then I take my fingernail and I run around like the first thread and a half, and I remove that material off there, so that for sure when I'm putting this together, that a piece isn't going to break off and fall down into the carburetor and cause that issue. So you can see I'm just kind of breaking off the extra and then laying it in really good to where with my fingernail it's staying into that groove, and there's not anything that's loose on that edge that's going to cause an issue in any way. Then I'll go ahead and start the thread pattern and get it started. And I'm kind of ensured that I'm not going to have an issue with it, right? Okay, so now what I'm going to do not over tighten this, because remember, pipe thread is tapered, so you can crack this housing. So, give it to where you think it's going to be tight enough to where it's not going to move on you. And then what I do is I angle it toward where the tank is going to be, so that this is going to be kind of angled about like that, and that's where I finish that out at. So now I'm going to peel this off. I'm going to do the exact same thing to this. Okay, so get it started, get it in there nice and tight, and kind of pay attention to thread right around the outside lip and try not to get it to where it's going to be over the top of that. Push it down really good and then inspect it and make sure that there's nothing that's going to get over that edge, and then it's ready to install. So now I'm going to go ahead and snug this up. Now, next thing you can do before you put it on is in this position right here, the float's at the bottom, so it'll accept air if you blow into it. When you flip it upside down this way and blow into it, you shouldn't be able to blow any air into this. I usually do it a couple of times, or you can listen to the float and make sure that you can hear it flopping around in there to where it's not hung up at all, right? So, but I usually try to blow into it first, just in case, you know, from shipping or whatever, that the needle is actually stuck in the seat just from sitting. So, yep, and it blows through fine. And it's sealed off. So I'm ready to install now. So I noticed when I turned on the fuel that it was real easy to turn on and off, and that the bowl is leaking fuel right here. So there's actually a packing right in behind this nut right here. So what I'm going to do is I'm going to put a little bit more pressure on the packing. That'll make this a little bit harder to turn in and out, but it'll stop it from leaking. Okay, so what I'm going to do to get my OCV and governor set right is I'm going to break loose this jam nut, and then I'm going to run the governor out and take the preload off of it so that this arm should have a little bit of play in it. I'm going to tighten it up a little bit more and get the play out of it. Okay, so now it's not loose and it's not tight, and that's where I want to be at. And then I want to see where this rod is going to go into the carburetor in the high-speed position. And it misses it by about probably 3/16 of an inch. So I'm going to break this jam nut loose here. I'm going to run this out. So push it all the way to wide open throttle, and then back it out about 1/16 of an inch. So it's still got to go out a little bit more. That's too far. Perfect. Now you can double check it, put it back in, push it all the way to wide open throttle. See if you can pull that out easily. If you can, then it's pretty well set. So that's where you want to be at on your starting. Now, when you fire this up in this position right here, right now, the governor's in wide open throttle, the carburetor's in wide open throttle, there's counterweights in here that flare out and pull this arm forward. When it pulls this arm forward, it goes to a mid-range speed, which is going to be your 1550, okay? So what I'm trying to do here is put the preload on it, so when I adjust it and you're striking an arc and welding, that this governor counterweights will be at the same consistency as what the carburetor is, so it can react to how you're welding, whether or not you're welding in second gear or if you're in fifth gear, then it'll pull that load and keep that weld consistent. So that's where I'm going to be at right now. Now, like I said, when I fire this thing up, it's probably going to be like at about 900 RPMs. Now, as I run this screw in, it puts more load on this spring, which doesn't allow the counterweights to flare out as much, which means if it can't flare out, it can't pull to lower idle. So the further you go in, the more preload it puts against the spring that allows the counterweights not to flare out as much, and it keeps it at a higher speed. So if the counterweights weren't able to flare out at all, then this would still stay at wide open throttle. So when it fires off, counterweights will flare out and this whole arm will go toward a mid-range speed. So my next step now is to go ahead and fire up the machine and go ahead and dial the rheostat to 100%. And you're probably going to see the DC is probably going to be around 70, maybe even 60. And then I'm going to work back and forth over here, and I'm going to run this fuel or this governor rod in for the RPMs to go up. And I'll keep an eye on it until I hit around 93, 95 OCVs. And the reason for that is because there's no load on the stator, and it hasn't gotten hot enough to where it's going to be at a stable amount for the full day. Once you weld like a half a rod with it, it's going to stabilize where it's going to be, and then you can dial it into where you want it at, 89, 90, wherever you feel comfortable with. Once you have that done, complete to where it welds good, and you're comfortable with how it welds, then you're going to attempt doing the low idle. Make sure that this welds exactly the way you want it, and adjust the low idle afterwards. Who cares about how it runs at low idle at this point? We want to make sure it welds properly, right? Okay, so the next thing we're going to do is we're going to do what's called a lean drop on the carburetor. So the carburetor, when it comes from the manufacturer, they preset it to a speed a spot that you probably wouldn't have to adjust, which is usually a turn and a half to 2 turns out on the fuel mixture screw that's on the back of the carburetor. Now, that they don't really know what the application for this carburetor is, so they give you a baseline to go off of. So what we're going to do is we're going to fine tune it into this engine. So I'm going to run the fuel mixture screw in until the engine starts to stumble, and then I'm going to back it out until the stumble goes away. And I'm going to do that a couple of times to find that sweet spot, and then I'm going to turn it counterclockwise a half a turn, and that should be dead nuts of where it should be. To be able to do that correctly, I have to make sure it's on the low idle circuitry. So I'm going to run the stop assembly out to where it'll just barely be running when I'm doing this. So I'm going to go ahead and fire it up and go ahead and start. You can hear it start to stumble. Now it goes away. Now it stumbles. Then I'm going to give it a half a turn. That's it. So I just tightened up this screw right here. I left it a little bit loose so it doesn't bind. Hold it to high idle or low idle and release it a couple of times to make sure it's not in any kind of bind at all. All right, now we're gonna go ahead and fire up the machine and see if low idle works. so the next thing we're going to do is we're going to set low idle so that it has enough voltage to be able to pick up a frequency for the reed switch to close together to release the solenoid so that it goes to high idle as soon as you strike an arc. Okay, so just a little recap on that. What I did was I had the rheostat at 100%, and on my voltmeter on DC, I wanted to make sure I had at least 35 OCVs, open circuit voltage, at low idle. That gives it enough for the reed switch to close and release the solenoid and go to high idle. If you have an OEM Lincoln instead of an aftermarket one, they're not quite, they're a little bit more sensitive, so you can actually dial it down a little bit more. You could have it at 26 OCVs instead of 35. So if there's anything that I missed on any of this, please contact us, leave us some feedback. You know, if you think there's some things that I was not correct in, please let us know. I appreciate it. Have a good day.